In this video, we're going to solve a system of equations where the problem is a transportation problem. Our 4 steps are basically the same 4 steps that we keep using. First, we're going to define the variables. Second, we're going to figure out what types of information we have. And in these particular types of problems, these transportation problems, it helps to organize it graphically. Then we're going to set up our equations, report our augmented matrix, and use the calculator to solve the system, and finally state our solution in a complete sentence with appropriate units. Here's our problem. A company has manufacturing plants in Seattle, Washington, and Atlanta, Georgia. You're in charge of the logistics of shipping its product to its 2 primary sales outlets in San Antonio, Texas, and Los Angeles, California. The Seattle plant can produce 500 units in a week, while the Atlanta plant can only produce 350 units in a week. The San Antonio outlet can sell 375 units each week, and the Los Angeles outlet can sell 475 units each week. Transportation costs are as follows below. So the Seattle to LA, that's $6 per unit. Seattle to San Antonio is $10 per unit. Atlanta to LA is $11 per unit, and Atlanta to San Antonio is $7 per unit. Assuming that you wish to fill all orders and assure full capacity production at both plants, is it possible to meet a total transportation budget of $7,670? If so, how many units are shipped from each manufacturing plant to each distribution outlet? I've drawn a picture that we can use to get an idea what types of information we have going on here. They told us in this statement of this problem that the Seattle plant can produce 500 units. So each week the Seattle plant has 500 units leaving the plant and going to the 2 different outlets. The Atlanta plant can produce 350 units. So each week, Atlanta can send 350 units to San Antonio or LA. And we can see that the San Antonio outlet can sell 375 units. So the San Antonio outlet can have 375 coming in. And finally, the LA unit has 475 units each week. So this has 475 units each week. Now notice that the sum of the 500 plus the 350, that's 850, that's actually equal to the same sum that we have here. And that'll be the case for all of these problems that you're going to see. Before we move on, they ask us, how many units are shipped from each manufacturing plant to each distribution outlet? So that's what we're trying to figure out. So we're trying to figure out how many units go from Seattle to San Antonio, Seattle to LA, Atlanta to San Antonio, and Atlanta to LA. So we're basically trying to figure out how many are in these little arrows here. Notice I have 4 arrows, one from each plant to each outlet. So I'm going to have 4 variables. I'm going to make them X, Y, Z, and W. And all of these are going to represent the number of units from like Seattle to San Antonio, Seattle to LA, Atlanta to San Antonio, and Atlanta to LA. So I've defined my variables over here, and I have abbreviated a bit. So number of units from S is Seattle to San Antonio, that's SA. Y is number of units from Seattle to LA. Z is number of units from Atlanta to San Antonio. And W is the number of units from Atlanta to LA. Now, another piece of information that we have is our information about how much each route costs for shipping. This information in here. So I am going to sort of put both the variable names and those costs next to these arrows. My X was the number of units from Seattle to San Antonio. This arrow represented my Y. This was Seattle to LA. Z was Atlanta to San Antonio, and W here was Atlanta to LA. And each of these routes has a cost associated with it. So it says, let's see, Seattle to San Antonio, that's $10. So this route is $10 per unit. Seattle to LA, that's $6. So this route is $6 per unit. Atlanta to LA, that was $11 per unit. So this route was $11 per unit. And Atlanta to San Antonio, that's this route, I'm going to write it up here, this was $7 per unit. So we have our information a little bit organized. The next thing we need to do is figure out how to build some equations around this organization and these variables. So I have my graphic again here, and I'm ready to start building some equations. So we're going to build one equation for each city. When I look at Seattle, I have 500 units available to ship from Seattle to San Antonio and LA, and I have X units going to San Antonio and Y units going to LA. So this tells us that X plus Y is going to equal 500 because I'm shipping all the units that I have available to my two outlets. I'm going to let you do the Atlanta equation on your own. Let's look at the San Antonio equation. For San Antonio, they have 375 units that they can sell, and we have X units coming in from Seattle, and then we also have Z units coming in from Atlanta. So we get X plus Z is going to be 375. Pause the video and you write the equation for LA and then the equation for Atlanta. Did you get the equation Z plus W equals 350 for Atlanta, and the equation Y plus Z, actually it's Y plus W, I'm not sure where I got Z, so Y plus W is going to be 475. The last equation that we can build is a cost equation. So they told us exactly what they wanted the costs to be. And if you go back and look at the problem statement, it says the cost was $7,670. So all we need to do is build a cost based on these individual per unit costs that we were given. The cost for each unit from Seattle to San Antonio was $10. We have X units going that way, so the cost for the Seattle to San Antonio units is going to be 10X. The cost for the units going from Seattle to LA was $6, and we have Y units there. The cost for each unit to go from Atlanta to San Antonio was 7, so that's going to be 7 Z units. And finally, we're going to have 11 W units. This should total to 7,670. Now, if we look here, I've got 4 variables and I have 5 equations. So hopefully we will get a unique solution. When we think about our augmented matrix, since I've got 5 equations, this tells me I'm going to have 5 rows in my augmented matrix, and I've got 4 variables plus 1 right-hand side, so that's going to be 4 plus 1 or 5 columns. So we're going to have a 5 by 5 matrix for our augmented matrix. We end up with this matrix here. So it's got 5 rows, 5 columns. Now I'm going to use technology, my calculator is what I'm going to use, to take this augmented matrix and write it in RREF form. My reduced row echelon form for our matrix is this matrix here. Now notice that as usual in my RREF form, I have 1s along the diagonal, but I don't have a 1 right here. That's actually good because remember I only had 4 variables, X, Y, Z, and W, and so I want to know what the values of each one of those are. So this row here, even though usually when we see the row of zeros that usually is a clue that we might have infinitely many solutions, is not in this case. That does not tell us that in this case. In this case, we just had one more equation than we absolutely needed in order to solve this system of equations. Typically, when you have 4 variables, you're going to need 4 equations. Our solution ends up being x equals 290, y equals 210. Our sentence should read something like, the company should send 290 units from Seattle to San Antonio, 210 units from Seattle to LA, 85 units from Atlanta to San Antonio, and 265 units from Atlanta to LA. Let's extend this problem. The question that we're going to answer is there a way to ship the product that would have a smaller cost? And usually there is. Notice 2 of our routes from Seattle to LA and from Atlanta to San Antonio, those are much cheaper than these other 2 routes, the $11 route and this $10 route. And so we're going to try to ship as much on these cheaper routes as we can so that we minimize the high-priced routes. Let's start by just trying to max out the cheaper routes. I have 500 units at the Seattle plant, and I need 475 units at the LA plant. So I'm going to make this Y be 475. I can't send 500 because LA only needs 475. Y is going to be 475 units. Now, if I think about LA here, if it's getting all of its units from Seattle, then it's not going to need any units from Atlanta, so we're not going to have any at that $11 price. We're going to make our W be 0. Now, if W is 0, then this Atlanta, plant has 350 units. None is going to LA, so all of the 350 units has to go to San Antonio. So this means my Z is going to be 350. If Z is 350, that leaves a total of 25 from the that I can send to the San Antonio plant from Seattle, which works because I only had 25 after I sent 475 to LA. So I have 25 here. So let's just double check here. X plus Y is 500. That's true. 25 plus 475 is 500. Z plus W is 350. 350 plus 0 is 350. Check the San Antonio. X plus Z, that's 25 plus 350. That does give me that 375. And the LA plant had 475 coming from Seattle, none coming from Atlanta. 475 plus 0 gives us 475. So that works. So our cost, we can just copy these numbers down here. When I add this all together, my cost ends up being $5,550. So we were able to reduce that cost. That's it for this transportation video. Thanks for watching.